Hi my friends, and welcome back to the You Can Do TV channel. In this video, we will explore modern house building technologies that speed up the construction process while ensuring the aesthetics and safety of the house. Somaco is a reputable company that specializes in intelligent construction solutions. They are known for their expertise in producing high-quality prefabricated concrete elements. The production process at here starts with the verification of the molds by their diligent quality control team. They meticulously inspect the molds to ensure they meet the required specifications and are free from any defects or flaws. Once the molds pass the verification stage, they undergo cleaning and lubrication. This step is essential to ensure that the molds are free from any debris or residue that could affect the surface of the concrete elements. Lubricating the molds helps in achieving a smooth demolding process, preventing any potential sticking or damage to the concrete. The next step involves positioning the embedded components on the molds. These components, such as reinforcement bars or inserts, are carefully placed according to the design requirements. The precise placement of these components is crucial to ensure that the final concrete elements possess the necessary structural integrity and functionality. After the embedded components are in place, the construction of the reinforcement cage takes place. Skilled workers assemble steel bars and other reinforcement materials within the molds. This reinforcement cage provides the required strength and stability to the final concrete elements. Attention to detail is crucial during this step to ensure the proper positioning and secure attachment of the reinforcement cage. Once the reinforcement cage is complete, the molds are ready for the concrete pouring process. The team at Somaco expertly mixes high-quality concrete and pours it into the molds. They ensure that the concrete completely fills the desired shape and form. Proper compaction techniques are employed to eliminate any potential air pockets or voids within the concrete, ensuring the strength and durability of the final elements. After pouring, the concrete is left to cure and gain sufficient strength. Once the curing process is complete, the time for demolding arrives. The molds are carefully removed to avoid any damage to the newly formed concrete elements. Skilled workers handle this step with precision to preserve the shape and integrity of the elements. Finally, before the concrete elements are considered ready for use, a thorough inspection is conducted to verify their dimensions. Measurements are taken to ensure that the elements meet the specified requirements in terms of length, width, height, and other relevant parameters. Any deviations are promptly addressed to ensure that the elements meet the necessary standards. Stress-light precast concrete is created by fabricating molds for individual concrete units and then filling these molds with a blend of GGBS cement mixed on-site. This process reduces house construction to a series of separate concrete pieces. One of the key benefits of precast construction is the ability to achieve precise finishes and aesthetics for each concrete unit. By utilizing advanced techniques, a higher quality product with greater accuracy can be achieved. Before reaching the construction site, every precast piece undergoes thorough quality control checks to ensure consistent and high quality standards. Designed on-site and manufactured in Stress-Light's factory, the precast concrete units are then delivered directly to the building site and swiftly installed. A precast frame package typically includes columns, beams, floors, wall panels, stairs, landings, and balconies. With a significant portion of the house being precast, the overall construction time is significantly reduced. In fact, it is possible to witness the construction of a 3-story house up to roof level within just 4 on-site days. Stress-Lite also offers a wide range of precast composite floor systems that can accommodate spans of up to 10 meters. These systems are highly adaptable and quick to install on-site, reducing the need for additional columns or joints. Immediate safe access for all trades on-site is ensured, and precast stairs are also manufactured in Stress-Lite's factory, facilitating quick and easy installation. This not only contributes to a safer working environment, but also provides enhanced fire resistance, durability, and strength compared to traditional concrete block construction methods. Precast concrete offers superior acoustic insulation between floors and rooms compared to other materials. Test figures demonstrate that a 150-millimeter concrete floor can achieve airborne sound insulation as high as 50 decibels. The speed and simplicity of design and installation also allow for layout flexibility, enabling clients to make changes to internal walls or replace load-bearing walls with beams, depending on their design preferences. Precast methods enable the construction of suspended balconies or cantilevers, opening up greater design possibilities. The quick internal construction method allows trades to efficiently plan and execute services such as electricity, heating, and plumbing, preventing scattered pipes and conduits. This leads to better maintenance and management of the home in the long run. Furthermore, precast construction is environmentally friendly. The materials used in precast slabs are sourced close to Stress-Lite's factory, reducing transport distances and the use of fossil fuels. Additionally, precast construction reduces overall concrete usage in a house by up to 20%, while on-site construction waste is almost eliminated. The tilt-up construction process starts with the formwork, often made of wood or steel, is set up on the construction site floor. The formwork creates the shape and structure of the tilt-up wall panels. It is reinforced with steel rebar for added strength. Concrete placement and panel casting. Once the formwork is in place, the concrete mixture is poured into the forms. The concrete is typically a high-strength mix designed for tilt-up construction. Any architectural finishes or textures can be applied to the concrete surface before it cures. Curing and panel preparation. The concrete panels are allowed to cure and gain sufficient strength. During this time, any necessary lifting inserts or anchor points are embedded in the panels to facilitate the lifting process. Panel lifting is the critical step in the tilt-up construction process that involves carefully raising and positioning the concrete wall panels into their vertical position. It requires specialized equipment, such as cranes or forklifts, and a well-coordinated effort by the construction team. Before the lifting process begins, a metal structure referred to as a lifting and support mechanism is attached to the top edge of each panel. This structure is made of steel and is securely connected to the embedded steel plates, or embeds, that were placed in the panels during the casting phase. The lifting apparatus is designed to distribute the weight of the panel evenly and ensure a safe and controlled lift. Once the lifting mechanism is in place, the construction team operates the crane or forklift to carefully lift the panel off the ground. The lifting process requires precision and coordination to avoid any damage to the panel or injury to the workers involved. The panel is lifted vertically, gradually and smoothly, guided by the lifting apparatus. As the panel is lifted, the construction team ensures that it remains stable and balanced. They use additional bracing and support systems to keep the panel in position during the lifting process. Once the panel is clear of the ground, the crane or forklift carefully maneuvers it into its final position, aligning it with the previously erected panels. Once the panel is in place, it is secured to the adjacent panels, and any necessary adjustments are made to ensure proper alignment and fit. The process is repeated for each panel until all the walls of the structure are erected. Metal structure elevation. As the concrete panels are lifted, a metal structure, typically made of steel, is erected to support the panels and provide structural stability to the building. This metal structure serves as the framework onto which the panels will be attached. Panel placement and connection. The lifted panels are guided into their final position and secured to the metal structure. Adjacent panels are connected using various methods, such as welded or bolted connections, to ensure structural integrity. Roofing installation. Once the walls are in place, the roofing system is installed. In some cases, a KR-18 system, which is a type of metal roofing system, may be used. The roofing system is designed to provide protection against the elements and complete the building envelope. Finishing touches. After the walls and roofing are in place, any necessary finishing touches are applied. This may include painting the walls, applying exterior cladding or siding, installing windows and doors, and completing any interior construction activities. Earthworks and asphalt. Finally, any remaining earthworks, such as grading and landscaping, are carried out. If required, asphalt or other paving materials may be installed for parking areas or driveways. Building a wooden house, such as the Mutter-kind house in Niedergrunstedt near Weimar, is an excellent example of eco-friendly and modern construction. This particular house, operated by the Dr. Georg Haar Foundation, was designed to provide a healthy living environment for 8 mothers and their children. The construction process began with careful consideration of the local context and the surrounding village's traditional gabled roof architecture. The architects, Tectum Hill, Cobalt Architekten, took inspiration from this typology and reinterpreted it in a contemporary way. By offsetting the building volumes, they created terraces, gardens, and courtyards with high-quality outdoor spaces. To ensure energy efficiency and sustainability, the exterior design of the wooden house was consistently translated into the construction. The outer appearance features rough-sawn larch cladding with a natural color, blending harmoniously with the surroundings. The primary load-bearing elements were constructed using prefabricated solid wood panels with thicknesses ranging from 8.5 to 15 centimeters, resulting in a fast construction process of only 3 working days. Inside the house, the natural beauty of the wood was preserved by leaving the surfaces of the solid wood walls visible and applying a whitewash, showcasing the simplicity and craftsmanship of the raw wooden structure. The house achieved a low energy standard of KFW 70 by incorporating 20 centimeters of insulation, a ventilated wooden facade, south and west facing windows, and connections to a solar thermal system and district heating network. The interior of the Mutter-kind house was designed to create a welcoming and healthy living environment. The pleasant tactile qualities of wood were utilized throughout the house, including the custom-built furniture. In an effort to reduce waste, leftover pieces of solid wood from doors and window cutouts were repurposed as integrated furniture elements. The architects paid attention to every detail, even concealing rainwater pipes, gutters, and flashing behind the cladding to maintain the simplicity of the building geometry. The communal areas feature a flat roof with skylights, floor-to-ceiling windows, and a direct connection to the outdoors, distinguishing them from the more intimate individual spaces. Horizontal, large cladding emphasizes this differentiation and adds an architectural touch to the facade. By combining ecological principles with modern design, the Mutter-kind house stands as a testament to the possibilities of wooden construction. It provides a healthy and sustainable living space while integrating seamlessly into the local context. The architects, Christiane Hill and Roberto Cobelt, successfully created a modern wooden house that is both aesthetically pleasing and environmentally conscious. DIY builder Christ Morse shows how he stacked and reinforced his ICF basement walls. Start by pouring the footings as the foundation for the walls. Use ICF blocks to stack the walls. Ensure that the blocks are of the appropriate size and type for your specific project. The blocks should be chosen according to the desired wall thickness and insulation requirements, ensuring they fit together securely and provide the necessary structural integrity. If your project involves constructing a circular structure, like the circular tower in the Hilltop House, use special bill block radius blocks designed for creating curved walls. As you stack the ICF blocks, add horizontal rebar reinforcement according to the specifications provided by your engineer. The horizontal rebar helps strengthen the walls. After stacking all the blocks for the basement walls, brace the walls and install scaffolding to prepare for the concrete pour. The scaffolding provides support and stability during the pouring process. Utilize the scaffolding to install vertical rebar reinforcement. This involves placing vertical rebar rods at specified intervals between the stacked ICF blocks. The vertical rebar enhances the structural integrity of the walls. Ensure that the horizontal rebar runs on the inside and outside of the walls, overlapping or alternating every course of blocks. This helps distribute the load and reinforce the entire wall system. Trim the ICF blocks as necessary to accommodate additional components or features. For example, if you plan to pour an 8-inch build deck on top of the walls, modify the top layer of the blocks to accommodate it. Use appropriate tools like a table saw or a sawzall to make precise cuts. Remove excess material from the modified blocks to create space for the build deck, but be careful to maintain the necessary attachment points and thickness of the webbing for structural stability. Repeat the stacking, reinforcing, and trimming process for all the required courses of blocks. Ensure that you follow the engineering specifications and local building codes throughout the construction process. In the case mentioned, the basement walls are stacked to a height of 9 feet 4 inches, with the 8th course trimmed to 4 inches to accommodate the build deck. Remember to consult with professionals, such as engineers and contractors, for specific guidance and to ensure compliance with local building regulations. The construction process of Stress-Lite precast concrete tank begins in the factory, where the precast concrete panels are produced. These panels are manufactured using high-quality concrete and reinforced with steel bars to provide strength and structural integrity. The concrete mix is carefully designed to meet the specific requirements of BS 8007 to 1987, a British standard for the design of concrete structures for retaining aqueous liquids. To ensure a superior finish and enhanced longevity, the panels undergo a rigorous vibration process during production. This process helps to remove air bubbles and compact the concrete, resulting in a smooth and robust surface. Working in collaboration with leading building contractors, Stress-Lite delivers cost-effective and high-quality tanks using the precast concrete manufacturing process. This approach offers numerous advantages, including faster installation and reduced on-site labor requirements. The construction of the tanks typically takes around 2 to 3 weeks to complete, after which a water test is conducted to ensure their integrity and functionality. This test confirms that the tanks are watertight and ready for use. One notable aspect of Stress-Lite tanks is their flexibility in design. Each tank can be custom designed to accommodate specific pipework and equipment requirements based on customer needs. This versatility allows for seamless integration with existing infrastructure and ensures a tailored solution for individual projects. Importantly, Stress-Lite tanks are renowned for their low maintenance requirements. The quality of the precast concrete and the precision manufacturing process contribute to an extended lifespan compared to alternative storage facilities. This durability and longevity makes Stress-Lite tanks a reliable and cost-effective choice for storing various liquids. In addition to the tank structure, Stress-Lite has developed a precast system for the roof and supporting columns. This comprehensive approach provides a complete solution for tank manufacture, ensuring consistency and compatibility across all components.